I'm going to switch over to the Jupyter Notebook to talk sort of a review of last class and then going forwards. So what are some of the things we unlocked last class? So Music 21 objects that we can use. Shout them out. What's that? Stream. Good. Pitch. Corpus, I heard. Anything else?
Duration.
Duration. And pitch and duration lets you do what? Note. Good. We remember that. And there's one other one I just want to remind you. We're not going to use it very much. It's called converter. Let me make this a little bit bigger. Oh, that's nice for me too. Sorry. Great. Because converter does the same thing as corpus, but loads any file on your hard drive or anywhere on the web. But since I don't know what's on your hard drive, we're not going to use it that much. Great. And what's something we did last class? What's the problem? Well, so let's all load that Bach piece. Everyone remember what I should type? Corpus dot parse. Good. And I said it was Bach BWV 66.6. The only thing you actually need is whatever's necessary to distinguish it from anything else. So you'll sometimes see I'm going to be taking a shortcut there. Good. And how many things were in Bach? Do you remember? Estimate 6. Oh, good. We have the exact number. Yep. Why? Where are the notes? We have a score object, I'm pretty sure, just to recall. Yep. We have score object, and then what's inside of it? The main thing, 4 of the 6 things. Parts, good. And then inside a part, Hannah, you had your hand up on the last one, I'll get you in. What's inside of a part? Measure objects, good. And what's inside the measure objects? Notes and other things, but primarily. So we have this hierarchy, this nested hierarchy, score, parts, measure, notes. There may sometimes even be another level of hierarchy. For instance, in scores like this, where you have 2 different voices on the same part, there may be a voice object inside of a measure. And if you have a whole collection of scores, we call it something begins with an OP. Opus, yeah. So you can have something that's bigger than a score. You can have opuses, opera technically, an opus that has scores inside it. And then you can put opuses inside opuses because I didn't want to make anything bigger. Yeah, go ahead, Misha.
Can we close the door?
Oh, yeah, sure. Can you close the door for somebody who can get there? Thanks. Thank you. Appreciate it. Great. So how did we get down to the notes last time? We did something like for thing in score. You don't have to type this as all review. In Bach, if we remember the is instance is the Python way of figuring out saying thing in score is stream.part. We can also just say stream.stream. If it's some sort of a stream, then for thing in part, in thing in score. I don't want to waste too much time on this. I can do this. If instance thing in part. Somebody tell me if I type something wrong on this, because I'll probably do it, and that's not there's no tricks on this. For thing in measure in thing in part, print thing in measure. Hopefully that works. Yep. So that lets us get down to the lowest level of what's happening here. We have a whole bunch of notes. What are we doing? Are we doing, you'll remember the 2 representations. The box representation or the salami slice time-wise. What are we doing? Are we going through all the parts here first, or are we going through one part and then another? Hint, you can always look back at your score. You know the piece, and you have the notes. go ahead and when you have it, just look up and then shout it out. We're going part by part, right? The soprano, C sharp, B, A, B, C sharp, fermata. Oh, it's nice to see that fermatas are not in here, so they must be someplace else. E, C sharp, yeah. So we're going part by part in this case. Great. And we also saw last class that we could do something, if we knew exactly where something was, we could say Bach 2, which I happen to remember there's a metadata, soprano, then alto, so that would be 2. I don't know, let's choose a random measure. And we can make a list out of this. I can't remember if I think I demonstrated that, and get what is in here. And we'll keep seeing that these random other things keep popping up here, like system layouts and so on. We'll need a better way to get to notes. Questions, this is review, so I went pretty fast, but the important thing is if I'm reviewing it, it's probably important that we have good understanding before we move on. Yeah, Jake.
Where does recurse on the first area use that?
So we're going to get to that in just a second. Yep. Good. Yeah.
Close that.
Sure. Great, great. There we go. Sorry that the blackout blind over there doesn't seem to be working. Should, if you email me after class, I'll remember to put in a facilities request. Or if you email me right now in class, you'll hear a ding. Then I'll put in a facilities request, because that's going to get annoying as after daylight savings time starts for this class. Good. OK, any other things that we want before from the review last time? Yeah, I showed a whole bunch of things on the first class that are not done yet, but we'll be getting to them sooner. So assume everything on the first class, I think I said at the end, was then immediately relocked. But as far as this recurse thing, we're going to get to it and unlock it in just a few seconds. Great. So any stream can be converted to a list by doing it, so we can get the list of everything that's in the top level score for Bach here. And then we can do other things. And we can, there are some differences between a stream and a list that are pretty important. So when I say a list array in other languages, what are some of the things you can do? It's a mutable container. So what some things you can do to it? Yeah?
You can add to it.
You can add to it. Great. Other things? Usually you can add, yeah.
Pop things.
You can pop things off of it. Great. You can remove things out of it. What are some other things that lists do? Yeah, go ahead.
You can change things at certain indices.
You can change things at certain indices. Yeah, you can replace one thing with another. Good. Any other things we can do? We're getting... Yeah, Jason.
Find the length.
You can find the length. Great. You can find the length, and you can append to it and change the length. All those things. One other thing, beginning with IT, that you can do. Yeah, John.
Iterate over it?
You can iterate it. You can put into a for loop and get things. Great. Great. Any? There's one more over here.
Splicing.
Splicing. Yeah, you can get little parts of it too. So in this way, a stream really does work like a list. We can get rid of that metadata. We can get rid of other things here. If I had been smarter 20 years ago, it probably would inherit from list, but it does not. But it has a lot of things that are like list-like. But there's some things that you can also do that are a little different. Let's get, actually, what was that over here? We went up to Bach 2, 4. Let's get that out here. I think that should be measure 3. Let's see. M equals this, and we'll see what M is. Yep, measure 3. Great. So measure 3 of the second thing up here, so the third thing, because we're doing 2, 0, index 0, 1, 2, measure 3 of the alto part. here is something that I don't think, for all the amazing things MIT CS training does, I don't think it does very, very well. I think that this says measure 3 of the alto part. And here's the contents of it. Let's just go through and make sure. Remember, pickups are measure what? 0. So let's make sure that this is actually measure 3 of. Is that right? Do we get the right measure? The next problem set, the one that we're going to be talking about at the end of class today, it's probably the least time consuming of any of the ones you've had so far. So whew, good. I figure every third one you need a little bit of a break. So we'll go down on that. I will tell you in advance where people lose points on this problem set, is that they write the code works, and then they go on, and there's a little programming error somewhere that could have easily been fixed by looking at the score during show and checking that your answer was actually what it should be. So just to have that there, and that's now my feeling is everybody can get an A+. We can all get perfects on everything. I don't need to play gotcha games for ha ha ha. Now there's nothing to mark off. So good. So make sure that you're always doing that, and make sure to do these, call them sanity checks, that you're getting out from your data what you should be getting in. Okay, so these are some things that are similar. One of the things, though, so we have this measure object, and we'll look, oops. Shape of your brackets does matter, right? You have something here. Now, if this was just a normal list, m.insert 2, we're going to put it position 2. Let's put a note.note. Let's do one that we can immediately recognize. A double flat 4. Okay? We can create an object in here. Actually, we'll be smart. We'll call that n and define it before n equals, so that we can reference it again. Sorry, I'll try not to get this at the very bottom of the screen. Great. So what should have happened if this were a normal list? Where would you expect it to see that double flat, A double flat? Adam?
After the G sharp.
After the G sharp. I think that everybody agree? Sometimes everybody agrees when the professor's like, yeah, does it go after 2 or does it? I can't remember, but yeah, I'm pretty sure that's right. So it should be somewhere over here. Why is it here? Let's go back to that alto part, measure 2, and see it's coming after the C sharp. Does the C sharp have a fermata on it or not? Just want to make sure we're all in the same place. Yeah, John's nodding his head, and John's almost always right on these things, so good. And yeah, so we have it on the last ya of that word that I'm not going to say during Lent, right? And good. So it's coming right after there, and yet we said we should put it at 2. What might be happening here? Yeah, John.
It's being put of like the second beat, 0 index.
The second beat, yeah, with the beginning being 0. Now, I told you that's very, very close to the right answer. So great. I said at the beginning there was a reason why I didn't like to use beat as a fundamental unit. What was that? Or if don't remember, because of things like 5/8, where the fast 5/8, 1 and 2, and where beats can change their duration even within a measure. So what's something equivalent? What were durations measured in? I'm going to call on Misha next, but I want to make sure that we have, yeah, Misha.
Yeah, I think it was just, I think you said you used quarter notes as your notes.
Yeah, so quarter length. So in this case, it's exactly the same as beat. So this correct answer in this case, because we're in 4/4, right? But So we've put it in, what do we have? Eighth, so that's all within 0, 0.5, 1, 2. Okay, but there might be a problem here. Why is it after the C sharp? Well, let's do this. We remember some of our iteration. For, I'll still say thing in M, even though they're mostly notes. Print thing, and thing's new term that we haven't seen, it's offset. So the offset, just like the duration is measured in quarter lengths, the offset from the beginning of the current container is measured in quarter lengths. So we have here, and we can actually now have two notes at the same time. So you can have multiple things at the same position. That makes it a little bit harder to remove by offset that you want to have, because unlike in an array where there can only be one thing at a particular index, here you can have multiple things at the same index. This is a simplification. We'll see in a little bit that notes and everything else can have an infinite number of offsets simultaneously. But this is good enough to start here. Yeah, go ahead.
So if you do show, it doesn't like put them in the same place.
If you put it in show, it doesn't, right? Because not, that's a great thing. You're going to find it is easy to create things that are valid musical concepts that cannot be shown by any of our sort of music representation software, our Muse scores or finales or whatever like that. Why? Because do you usually, if you have a part, do you have two? This is an ontological question. Do you have two notes that sound at the same time in one part? Or do you have something else that happens when you have two notes at the same time? What other representation might be for two notes, for two things that sound at the same time? I won't say notes. Anybody? What do we?
Different parts.
You would have you could have it in two different parts, which is what we've normally seen. Or yep.
You can have like a split, like one person like going up and down.
Yeah, you see, you can have a split. Yeah, a split. We'll call those voices. In this case, you have two voices at that thing. What's the other thing that another fundamental part of our ontologies? Chord. So in this case, your software wants me to have created a chord object, which is not yet unlocked for us out of these two. So it just does whatever it wants with it. Great question. Super. So keep playing with the limits. We're a little bit behind on time because we're really asking great questions. So I'm going to hold off a little bit on some until we can get a little bit further into some things. So let me, yeah, question. Go ahead. How do you remove? Well, you'll be able to, you can either remove the thing and it will find it, or you can remove something at an offset. And we'll get, that will be, fortunately, all of these other things will be, all these other options will be revealed to you in the reading before next time we meet together, which is the user's guide chapter on streams. So I think that remove is mentioned in there. It can be a little bit more complicated, as I said, so I want to hold that off for just a little bit. Okay, let me do another little thing for a second, and we'll jump to some ways that we can make our life easier by not doing for thing and thing, then for next thing and next thing and next thing and previous thing. Obviously, we're going to have some other ideas. So this is one notion, one way of a score. A score might be represented in Music 21 with two parts. And so within the score, in this, its score's length is how much? Just shout it out. 2 or 3, because we have this metadata. And so I've put underneath is the offset of everything. Both parts start at the beginning of the score, right? So they have offset 0. Within part 1, there are two what I'm calling measures, measure 1A, measure 2A. Their offsets are at 0 and 4, which makes sense because somewhere in here there's a 4/4 time signature, right? And notice though that when we're looking at measure 2, measure 2's offset is 4, but we start again with offset 0. So if you want to know how many quarter notes into the piece quarter note 9 happens, you'd have to add 2 plus 4 plus 0. Fortunately, adding 0 is easy, so you get, it's 6 quarter notes into the piece. So this is one, the representation that's happening. Now, when you iterate over the score for, I'll sometimes use L, element. Things comes off the tongue better, but L is quicker to type. And when you do this, you'll see that we've already seen you get the metadata, you get part 1, and then you get part 2, and that's all. Right? So you get the 3 things that are there. The more powerful way to do this is something called recurse, the recurse method on here. And what this does is it goes through the first thing, and then if there's anything inside the metadata, which there isn't, it's not a container, it would go into it. Then part 1 is a container class. All containers are called streams, but the general term in computational music theory is the container. And then within this container, we have another container, and it will go through these things that are not containers. Sometimes these are called leaves, the leaf node, like in a graph, the thing that has no descendants on it. And then it will go through the second one. Then it jumps back to part 2 and goes through each one and tells you that. So that's going to make life a lot easier. Let's recurse through. Can I move over? Here we go. Let's recurse through Bach. For L in Bach.recurse, print. Let's do L and L's offset. Oops, and now I have to get my scrolling back. Go. So now we're seeing, there's the metadata, there's the soprano part. If we were writing a program, we could keep track of what part we're in at a certain point, and every time we see a new part, do something, and then we see, we're at measure 0. Here we go. Here's all the different things to measure 1, measure 2, and if I scroll far enough, eventually we should see, here we go, part alto. So that's it's pretty good. There's all this information about what's its offset and things. This can be done, also gotten in a way that just prints. It's not useful for parsing. I would not say parse this. But if you do Bach.show text, and it just gives you basically the same information as that routine, but nicely formatted. So I'll give a second where the current offset is given first, and then the next thing also puts everything like this. Questions on this part? Okay, now your computer science question. Recurse is what type of graph search? Don't shout it out yet. Let everyone think. There are a number of ways of searching through a graph or iterating through a graph. What kind would we call this? Usually, I'll give you a hint. The second word is usually first. Okay, that wasn't much of a hint. So, okay, raise your hand if you're confident that you know the answer to this now, and go like this if you're not confident that you know the answer. Great. Could you talk with the person next to you, and especially if you have a couple people who aren't so confident, and share your answer and see if you're in the same boat. Okay. Who is now a little bit less is still unconfident? Who's didn't come to an agreement on your thing? You guys are still in disagreement. No, you're in agreement. Good. Good. Okay, so let's all shout it out at us. The kind of search is a first search, a depth first search. Good. So we're always going to be following the leftmost. I should do this in different colors so it's easier to see. Right, the leftmost node that we haven't yet seen, and doing something with that, and then going back up here, going back up, down. Right? Does that seem to fit other people's computer science things? I have neither a concentration, minor, major, or PhD in computer science. So please, if I get something wrong, you all shout to me because you've done more of that than I have. Okay, great. So we have depth first search. What are some of the things anybody knows from other things that depth first searches are good for, and what are some of the things that they're not good at? So good for, anybody wants to say? Don't worry, it's a safe space. And
Shortest path problem.
shortest path problem, good. Good, shortest path problem. Anybody, do you want to explain, or anybody else want to explain what that is for those who haven't? Shortest path between two nodes, right? How to get there, right? You might not want to do something else it might be good for. Yeah.
It's just when you're in a scenario where you think you want to look over like every possible option.
Great. When you in a scenario where you want to look at every possible object. Now that there's other search methods that also have that property, but this one has that property. So it's already a lot better than for thing and thing than thing and thing, thing and thing, right? You know that you're going to get to every point. What's something it might not be good for? That another search method might be a better way of doing it. Yeah.
In case of like breadth first search versus depth first search, like if something's close by, if there's not like a lot of it, or the tree's like super deep, but the answer's like super close.
Yep.
Depth first search will search through everyone, or like to go to the depths of the tree. Or
Tree.
like, just to check in the first couple.
Great. Super, super. And we should say what we're comparing. There's lots and lots of searches, but the two key ones, we have depth first search, and it's compared to what? Breadth first search. Yep, the breakfast search, as I always say. Breadth first search. So that one, what are we going to do if we want a breadth first search in here? What are we going to see first? What's the first node we're going to visit? SC, the score, right? Good. So far it's exactly the same as a depth first search. Second node we're going to see in this hierarchy. Part one, good. Third node? Part two. Ah, okay, so we're already different. Next node? Was one? Yep.
So isn't BFS better for shortest path searching rather than DFS?
It depends on how you're doing your path. If you're looking for like distance one length paths and you want to find the first one that gets you there, that's
Right.
better. But if you're doing like positive length distances, then DFS is better.
Trying to remember the exact, what I remember which one of these.
Like A star or something, that'll get you even better.
Yeah. So we'll get to these particular types of searches later. Controversy in the class, I'll try to remember exactly which one. Do we have a, but yeah, I'll trust that we'll solve that because we're not going to be doing shortest path yet in this class. But we'll see that there's certain advantages to one versus the other. The other thing, so what's a musical thing that we want to, how about this? Do all parts start with the same key signature? Breadth first or depth first? Which one's going to be fastest to get you your answer? I heard depth and breadth. Who's on depth? Who's on breadth? Yep. Okay, good. So we're going to want to have both types of searches available. So recurse will give you always what do you call it? The depth first search. There's another one that we're going to have, and you're going to see it's the flatten operation. And you're going to see it sometimes in my old slides. I haven't figured out how to update dot flat, but it used to be a property. That is to say, you didn't need the calls called flat. Now it's a method called flatten thing. There were two reasons for this. One, if anybody has a new, uses an IDE like VS Code or PyCharm or something like that, which I highly encourage you to do. It's nothing elite to use Veeam anymore in life. Then a lot of those will now go through and call and check every one of the properties at a certain point so it can repeat for you. And flat ended up being, for a very, very large score, very space and time sensitive. And so I was, once I upgraded to a thing, I realized, okay, that can't work anymore, that flat. So we had to do it this. I also wanted to make it a few more letters so that people would stop calling flat instead of recurse just because it was less to type. So now they're much more equal. Flatten. And what flatten does is it gives you the option of doing everything first that's at the same offset, everything. So we start with, I think I have an animation on this. The metadata again, we get one clef, next clef, both the time signatures, everything that's at the same point. When you have a half note here, we'll get both quarter notes before getting to the other thing. The other thing that flatten does that's different is you'll see the offsets are now, because it's flattened, they're now all relative to the start of the score. So because of this, they're implemented in different ways. Recurse, the breadth first search, just sort of has a little pointer that's going around, figuring out where I am, figuring out how to go back up to the next hierarchy level and walk around and do this. So it's very, very fast and not very memory intensive. The flatten, on the other hand, in order to compute where everything should be and which one is actually coming next into this hierarchy, and for historical reasons, flatten will take that same score and put it all into a new score object, a new thing, but with, it also removes all the parts and stuff. Flatten, there are no parts or anything. There's just the things, just the leaf nodes at the end. So you'll get the clef, the other clef, the time signature, the other time signature, and so on, all in a new stream object. And this is the first time when I was saying that a note might have more than one offset, because this is the same, oops, this quarter note here is the same as that quarter note there. So dot offset will be changing as this happens. This is something that will occasionally bite you, but usually not. What does, which offset does it tell you when you put dot offset? It tells you whatever the offset is in the last stream that you iterated over that has that object in it. So we call that the active site. So it tells you the offset in its active site. You will find that it's often you're looking at something in a flattened stream, that should say flattened up there, and you want to know something about, Professor Cuthbert said, get me all of the notes between offset 5 and 7 and tell me what measure they're in. Shoot, we've gotten all things 5 and 7 from the beginning of the score. The problem is we've lost all the measure information when we're here. So there is a property on all streams, .derivation.origin, which will take you back to the original, the place where it came from, so the pre-flattened stream. And that's something you're going to be working with a lot. This is an ontological choice I've made on how things are rated, how flattened versions of scores have a derivation to the origin of the original score. Now, I'll take questions on anything. It's pretty confusing. It's a lot to jump in. Yeah, Adam.
Last time, what was Burma in the German anthem encoding?
What was
Remember at the very, very top, I said it was the composer.
Oh, Bohem. Okay, so we're jumping quite a bit back. It's the location, Bohemian, originally a Bohemian song. That was a pop quiz to see what I remembered. Great. Any other questions on this material specifically, and then on anything? Okay, well, let's start by having a little bit of programming exercise time. We have this Bach chorale, BWV 66.6. Are there more? Yep, go ahead.
So does flatten mutate the object?
So flatten mutates, yes, it mutates something on every object called sites that keeps track of where things are. But it does not change a thing. There were some choices that, now that Music 21's 20 years old almost, there's some things that I would have done differently. And I think it's probably time for somebody who's younger and more ambitious and wants to do something for the next 20 years to come up with things, because I did not listen to our great software engineering professor, Peter Jackson's warnings against mutability in objects as well as I should have. And now I'm trying to make more things immutable. But you will find that a lot of things will, by default, not mutate, but then can, and objects can be mutated. So that's a great question. Everyone knows mutable versus immutable objects. You can change, you cannot. Lists are immutable. What is the equivalent of a list in Python that is immutable?
Tuple.
Tuple, good, good. You all say tuple here. I always learn it as tuple, but tuple. Okay, great. Super. So here's, any other questions before I go on to my question for you about Bach? Okay, here is the question for you to answer, and let's do this in groups of two, because it's much more fun to be talking to. Does Bach use more ascending notes or descending notes? Descending notes, or about the same? I mean, you might think the piece doesn't start off hallelujah and end right, and it doesn't go the opposite. So it must be about the same, maybe, but we'll see. So talk. Everyone know who they're going to be paired up with? So paired. It's easier if you're sitting on the thing. Sit paired. Great. So start talking about how you're going to do this, and which type of thing.
I have a quick question. Why does flatten show?
Flatten? Why does flatten show? Because it's able to. Because recursed is not a stream. Recurse isn't. Yeah. So I should say recurse just gives you an iterator around that. You could do recurse thing, and then there's a dot stream that you can put onto it, and that'll give you a stream. But it's just going to give you the same thing you started with, because, yeah. No, then do it. Then, yeah, thank you. Always say, we're going to talk first about how to do it, and then implement. But I don't care. It's in class. I don't care however you'd like to do it, but always start talking, then implementing. Okay, I'm hearing the discussion start dying down and hearing some clicks. You can keep talking, but just an informal poll. Which groups are on Team Flatten? We got 1, 2, 3. Good. Which groups are on Team Recurse? Is the best way. Good. And which groups are in Team for Thing and Thing and Thing and Thing and Thing? Okay, there's one. No, there was a smile with that one. Okay, so keep going. There's ways to keep working on it. I think you'll find there's one that's better than the other, but we'll figure out which one that is. And if you're lucky to be sitting next to a group that's on the different team, maybe talk across groups and figure out, we'll dialogue across religions and political views. I'm going to interrupt for one second to say something that I've heard. Just a second. Yeah, just 1 second. Can I interrupt for 1 second to say something I have heard from two different groups? Matthew, introduced for 2 different groups. I have heard this something like, "Ooh, but think of the memory. We're going to have to keep a reference to the previous note." What is, to keep a reference to the previous note, what is the big O memory consideration that we're thinking about?
1.
1. Do we care about O of 1 memory?
No.
No, we do not. Good. Keep going with that. Just wanted to make sure that we had that. We don't care about O of 1 operations very often. Occasionally, but just this piece. Oh, it was just this. I just heard. Is it just this piece or all of Bach? Just this piece is what I'm asking for. But you could do for chorale in corpus. Dot. So you can, Derek and Vincent, if you wanted to, there is a for loop you can do above it. And since we unlocked corpus, that will give you all. Looking good. Looking good. So if anybody's finished and has gotten a thing, a couple of questions. Once you have that, they're not exactly the same. I'll say that. And what are some features in the chorale that explain that? The other thing you could do is do this for all 360 chorales. That's a lowercase c in chorales. Corpus.chorales.iterate. Okay, just before we go, who is still on Team Flatten? You used Flatten a little bit? Okay, and who actually, you will say who used Flatten anywhere in their score, and who used Recurse anywhere in their score? Okay, I'm curious how did Flatten work for getting this? Did you do?
We have the same, she used Recurse and I used Flatten it, and it's the same for ascending, and then for descending we're off by 2.
Interesting. I'll be curious to see how that happened. Great. So I think we're wrapping up a bit. You can keep working. Obviously, I'm what is it? Item 9 on your thing, sound to score. It's one of my favorite things to teach in class because it's really, really fun. But I have made a video so we can save some time outside, and that I'll add that. That's about a 10-minute to watch. There's trying to make it quite a bit easier on this weekend. Try to make it a little bit lighter. So it's just some interesting added things that are happening there. And for the first time, I'm going to really recommend that you read the Music 21 User's Guide chapters. There's an optional one, chapter 26 at the end. You don't need to read it because it's a little bit complex, but if you do read it and get through it, there are some tips in there that can make some aspects of the problem set 3 a little bit easier. So any other questions on what we did? Oh, one last thing on this. I always recommend, and I really, really recommend readable code. Write readable code. Write code so that you can do this collaboration and give it to friends. Write things like that. But 1 year, a while back, the class did decide to go code golfing on this particular thing to see who could write the shortest code to do all this. And oops, sorry.
Why did they do that to the eyes?
Because back then we were using Piazza for a discussion board, which used a proportional font. So using eyes it makes it a little bit more inscrutable. So never write code like this, but I do believe that works if you want it. And your prof won, but see if you can beat that one. Thanks, everybody.